hope you have all been well since last week. And today again, we are here to our 2 hours of the which will be engaging, and I expect so much contributions and questions for us all to be in one platform and common understanding. So as mentioned earlier, today we are going to look at the integrated environmental protection and water scarcity. It's generally how environment is affected by the industrial processes operating in our Tanzanian land. And my name, as usual, I'm Dr. Clarence Kisiki, who will be training you today for the second time. And this course is going to cover water use in industrial operations. And also we'll look at the environmental protection in industrial processes, groundwater protection and water scarcity for industrial processes. So generally, the overview of this program generally, because of the growing demand for the skilled water and environmental management professionals in sectors of industries, and also the need for sustainable environmental protection and conservation, where we need to bridge the gap between theory and practical applications. So IWAMI has come up with this program, which is a blended learning program. It's, now it has been done in several countries, such as German, Tanzania, and other countries, but now it's our turn, Tanzania, in order to look for the market-specific content for the Tanzanian context, and focuses on the practical application and real-world problem solving. Before we continue, I will kindly want to know who is attending today. Kindly, Ms. Mwamini, can you guide this for the participants to tell us their names, background, and the expectation for this particular program?
Okay, thank you so much, Dr. Clarence. So we'll start with Benjamin Shadrack.
Yes, hello, Mwamini. Hello?
Yes, we can hear you, Benjamin.
Yes, apology. I was actually sorting out somebody here in my office. So kindly can you please repeat something that you wanted to hear from me?
Okay, Benjamin. So we just want Dr. Clarence and the rest of the class who just want to hear a bit about you, maybe your name, your background. It's just a small repetition of the session that we had last time. Yeah. Yes.
Okay. So thank you. Good afternoon, everyone. Once again. Yes, my name is Benjamin Shadrack. I'm a water treatment manager at Tanzania for Davis and Shatcliffe, where I've been working here for the past 3 years. So I'm dealing mostly in water treatment projects, including the wastewater, doing the designing, the implement, and the execution of the work, and overseeing the business for Davis and Shatcliffe for Tanzania in that part. Yeah, I think that's it.
Thank you so much, Benjamin. Up next is Concedo.
Yes, good afternoon. Hello?
Yes, we can hear you.
Hello?
Good afternoon.
Okay. Good afternoon. I'm Concedo Conrad. By profession, I'm a registered environmental expert by name. So I'm thankful to join this module so that for me to gain more knowledge on the environmental issue and the water issues. Thank you.
Thank you so much, Concedo. Up next is Elizabeth.
Hello.
Hi.
Hello.
My name is Elizabeth Samuel from Women Tech Network.
Okay. Thank you, Elizabeth. Flora.
Hello everyone, good afternoon.
Good
My name
afternoon.
is Flora Ndosi. My name is Flora Ndosi. I'm a recent graduate from Water Institute and currently working at latest test company as a trainer and sales support. Yeah, my expectation is to learn how to use water responsibly and protect the environment. I'm looking forward to the discussion. Thank you.
Thank you, Flora. Up next is Mr. Mrema.
Yes, good afternoon, everybody. My name is Frederick Mrema, and I'm working with Jones Hansen and Sony Tanzania Limited. We are trading the water solutions and the water projects in general. Thank you very much.
Thank you, Mr. Mrema. Up next is Jasmine.
Good afternoon. My name is Jasmine Musa. I'm working with 17 global goals and the United Nations.
Thank you, Jasmine. Kennedy.
Okay, thank you very much, Mamini. My name is Kennedy Alex Mapunda, currently working at the Association of Tanzanian Water Supply as an operational manager. And today in this module, I look forward in learning the fundamental uses of water in industrial process. Thank you very much.
Thank you, Kennedy. Lamek. Lamek. Okay, Lamek is not ready. Oh, he's there. Yes. Yes, Lamek.
𝐀𝐻𝐿𝐴HK working at German-Tanzanian Tanzania. My presentation on this morning is learning about environmental protection and the water scarcity. Thank you.
Okay, thank you so much. Martha?
Hello. Good afternoon.
Good afternoon.
Good afternoon. My name is Martha Samuel. I'm a student. And
Yes.
on this module about
Martha, the voice is very low.
Martha, you're not audible. Could you move closer to the mic?
Hello.
Yes,
Can you
much
hear me
clear.
now?
Yes.
Yeah.
Okay. Okay, good afternoon, everyone.
Good afternoon.
Afternoon.
My name is Martha Samuel, and I'm still a university student for now. On this module, I'm expecting to learn about water protection in our environment so that we can get the clean water for the safe use and for the industry. Thank you so much.
Thank you, Martha. I think up next is Pendo.
This one. Hello, everyone. Can you hear me? Yeah. Okay, my name is Pendo. I work at AHK Eastern Africa together with Mwamini. I'm a project manager. Yeah, looking forward to this session and to engage with everyone. Thank you.
Thanks, Pendo. Up next is Sophia.
Hello.
Hi, Sophia. Maybe, yeah, okay. Sophia should be struggling with her mic. Maybe Stephen? Stephen? Okay. Sophia, are you ready to say something?
Yeah.
Okay.
Good afternoon.
Good afternoon.
Sylvester. I'm a recent graduate from Water Institute. My expectation on this module is to gain more knowledge on how to manage wastewater and to protect the environment. Thank you.
Thank you so much, Sophia. Stephen. Okay, Stephen seems to be struggling. Maybe we'll get to Stephen later. And last but not least, Constantine's.
Yeah, hello everyone. My name is Konstantin. I'm representing German-based company Rüdiger Vacuum. We're specializing in providing the solution for environmental protection, specifically in wastewater field. And I'm curious to learn what kind of initiatives and what kind of the dynamics going on in Tanzania in the direction of environmental protection, and also to see how all these dynamics and the trajectory moving Tanzania to SDG goals. Thank you.
Thank you so much, Constantine. So, Dr. Clarence, that's the class. We have a few students who are new, and I think Constantine's is the only one who is not from Tanzania directly. But yes, back to you before we later open the class for a discussion.
Thank you so much, Momini, for leading this session. So from here, let's continue with our today's lesson, and I hope we are all in board, and we'll get engaging session later after this presentation for everyone to come up with the contributions, ideas, and questions, and whoever feeling free to respond to any of the question may just feel free to do so. So as I say today, we are going to look at the importance of water in various industrial processes, and also we'll look at the water scarcity and impact of pollution into the environment, which is posed by the industrial processes. Also look at the efficient water use practices to reduce waste and ensure its availability. We'll also look at the environmental protection measures, which is practiced by Tanzania and other countries. We'll also look at the industrial water use, pollution management, groundwater protection, and strategies to mitigate the water scarcity in industries. So starting with the water use in industrial operations, we saw in the last module, we had tried to give the overview of this in a nutshell, that water is so important into industrial operations, and it is important into direct operation, such as maintenance of the equipment, cooling processes in the lubrication, cleaning the materials, and also in steam production. But it can also be used indirectly by processing the material before it's processed. And also it can be used as a source of energy It can also be used in a supply chain management and also in influencing production schedules and transportation of the raw materials. So if we look at this diagram, we will see that it shows the groundwater abstraction from freshwater bodies, which is surface water and groundwater, which after abstraction, it will be directed to the freshwater process tank or treatment plant, which will be after treatment to standard that is required by the specific processing. Then
I'm sorry for interrupting.
Yeah.
I'm sorry for interrupting. I don't think that there is something moving, so I don't see diagram.
You don't see diagram?
Mm.
How about others? Can you see diagram?
No, Dr. Clarence, perhaps you can just reshare the slide or just open it as a presentation. There, now we can see it, but open it in a presentation format. Yes, like present.
Okay.
Yeah.
Now you can see?
Yes.
Yes.
All right, thank you. So if we look at this diagram, we see we have two points of water abstraction. Water can be abstracted from surface water bodies, which may be lake, rivers, or rainwater harvesting, or whatever source in the surface body, or from water reservoirs. And it can also be harvested from the groundwater system and will be directed to the water treatment plant, which will be treated to a standard that is required by a processing factory, because different processing needs different quality depending on what is the required expected product. For instance, in the food and beverage production, we need water which has good quality compared to the water that is used just as a washing agent or other cases. So after water being treated, then it will be transferred to the processing, but during the processing, there will be some uptake by the product, and also some water will be lost through evaporation, and then remaining water will be released as wastewater after the processing, and which will be released to the wastewater treatment plant, and finally it will be processed to a quality that complies with the environmental standards, and then will be released to the environment, being in an ecosystem or any other surface body that is nearby. But their compliance is so important. So water is essential in economic development and population growth, and due to this, it's the demand has been increasing with time, since we are having more industrializations, and we need more food due to growing population. So the water demand is increasing day by day. Since as we industrialize, as we increase population, the water sources remains the same despite the changing climate and other factors of such as land use, land cover change, which inhibit even groundwater recharge. So we may see that there are several challenges facing water sources or water bodies, but the demand is increasing. So due to this, Tanzania has come up with some of the programs for intervention, such as Water Sector Development Program, which has been there for some years now. We are now in the Water Sector Development Program Phase 3, which is focused in the management and improving the service delivery for all water users. And examples of industrial water use in Tanzania includes mine sector, which is reported to be abstracting 1,500 to 3,000 cubic meter per day for mineral processing and dust control, and also such as Barrick Gold Mine North Mara. We also have seen some data on the agricultural water use from Wami Roof Basin, which indicated consumption of 10,000 to 15,000 cubic meter per hectare of rice farming annually. And also textile industry was reported from Tanzania Textile Mills, which was reported to abstract 50 to 100 liters of water per kilogram of fabric for cleaning and dyeing of the fabric. For the general processing, the industry needs 50 to 100 liters of water per 1 kilogram of fabric processed. But processed. And also, if we look at the beverage manufacturing, we'll see that 2 to 3 liters of water is required to process 1 liter of soft drink, which include processing itself and the cleaning of the bottles. We know the bottles are reused, so they need cleansing before the repackaging. So it's like 1 liter needs 2 to 3 liters. We can see how much industries need a lot of water in its daily processing, and the demand is even increasing for these products, and we are not having alternative sources of water. Now we'll look at the integrated environmental protection in industrial processes. Now we need to define what the environment is. Everybody has his or her concept on what environment is, but we may define environment as the interaction of these systems, which is atmosphere, hydrosphere, lithosphere, and biosphere, interacting the ecosystem. And if the hydrosphere will be polluted, automatically the hydrosphere will be in danger, and biosphere as well, and the atmosphere. We'll see how these contaminants can move from one system to another in the following slides. So looking at the integrated environmental protection, we do have what we call pollutions. And pollution can be defined as a harmful substance that is released into environment that may pose a threat to the living organisms in a particular environment. Now, the integrated environmental protection is designed to minimize adverse impacts, environmental protection with effective industrial processes. Now, how does this work? The integrated environmental protection works through reducing waste production, and also through resource optimization, also through energy, using efficient energy, and also recycling of the end products, or we can term it as applying a circular economy. But why do we need to protect or to integrate environmental protection? Is just to lower industrial footprint and enhance cleaner industrial production. So if we look at this image, we'll see how these pollutants can enter the environment system and cause harm. So if we look at this is an example of mercury emission from the mine sector. Of course, most of these small-scale miners, they use mercury in the extraction of gold, which is really dangerous for themselves, in their health, and also to the environment and other biodiversity. So if we look at this,
Dr. Clarence?
Yes, sir.
Dr. Clarence, I'm sorry for interrupting for the second time, but I don't think that the slides are moving. I think we're still on the factory slide, water use and industrial operations. So if it's possible to fix it, would be great.
Thank you, Constantine. Maybe Dr. Clarence, I'll try to project
All right.
and maybe try to move it from my angle.
All right,
Okay.
no problem. Yeah,
Okay.
sure. Let me stop sharing.
Okay. Stephen, can you mute? Okay, thanks. Okay, pardon the interruption, everyone. Can you please confirm that you can see my screen?
I'm not seeing your screen.
No. No.
No.
No. Yes.
Yes, now we can see.
Sorry, is that the correct slide?
No, before this.
This one.
Yes.
Perfect.
Next one. Yeah. Thank you. So I was explaining on the movement of the mercury to the environment from the small scale miners. And I was saying most of the small scale miners, they use these heavy metals for extracting the gold from the parent rock, despite of its health hazards to themselves and to the environment and to the ecosystem. So if we look at this image, we'll see in the top left, it's this is a grinding of the rocks, which is mined, and then after grinding, they usually wash, and after washing, they would now the remaining sand will be poured with mercury, and mercury usually captures all the gold from the rest of the minerals or rocks, and then they will burn the mercury for it to evaporate, and they will remain with the gold nuggets in the burning pan. So if we look at this, then now we'll have mercury evaporated, we'll have mercury released to the water bodies, and also it will be released with the tailings in the environment. And at the end of the day, it will be consumed by the aquatic organisms and people who are consuming such water. It may be, the water may also be used for irrigation, and the heavy metals will be uptaken, which will be consumed by human beings and end up accumulating concentration of heavy metals in their bodies. And also, if it's taken by the fish, then if people eat fish, they will also keep accumulating the percentage of heavy metals in their bodies. And as a result, we all know that these are the carcinogenic materials. So at the end of the day, you find people suffering from different diseases without knowing exactly what was the source. So we see these are the impacts which industrial processes may release to the environment, can cause an adverse impact to the biodiversity. Let's go to the next slide. So if such as cadmium also, it's this is also a heavy metal which is a byproduct of different industrial processes, and it can be released to the environment, which can be uptaken by water, and water can be used for agriculture and other uses, and also it can be released to the soil, which can be used for industrial, and also the plant can take the heavy metals, and also it can be uptaken from crops as food and other marine products, and it enters the human body through different processes. When it is suspended in air, then it can be breathed in, and by drinking, it can be taken by food plants from soil, and also it can be taken by cooked food also, because when we cook food, we don't the heavy metals persist, the heat that cooks food. Let's go to the next slide. So if we look at this diagram, it indicates how pollutants migrate to the water bodies. Now, if we look at this image, we'll see we do have pollutants can be released from a warehouse. It can be released to the unsaturated zone, and finally it infiltrates to the saturated zone, which is a water table. That is how groundwater will be polluted. And also it can be released from a production house, which will also, if we have leakages, it will also be released to the groundwater system. It can also flow, the wastewater from the production can also flow as in a drainage system, and it will be released to the wastewater treatment plant. But if we do have leakages in this drainage system or in a waste treatment plant, the waste will also be released into the environment. But also, if after the treatment, the treated water should be released to the environment. But now we do have several standards that has to be complied before the waste, the treated water is released to the environment. But we know that some of the industries does not work on complying with the stated standards. So some industries may end up releasing this wastewater directly to the environment, which has very very worse impact to the livelihood of the organisms that have their life in this nearby environment. Let's go to the next slide. Thank you. So, having seen all the pollution sources and migration to the water bodies and to the environment, now we have it's important to manage this continuous pollution, and due to the need for the management, there are several factors that are in place in different regions and countries that limit or control the waste released to the environment. And we do have better pollution control, and the pollution control can be monitored in different standards of the effluents that are to be released to the environment. There is what is called Uniform Effluent Standard. This is the permit that is given to the industries which wants them to treat these effluents to a standard, to a uniform standard that is stated by a particular permit. But also there is a sector-based effluent standard. This is depending on what is the water use and where are you disposing the effluents to. So the standard depends on what was the water used for. For example, if the water was used in a domestic use, its treatment should not be uniform to the water that was consumed in maybe textile processing industry. So you see the contents will be different. You see some having heavy metals and some having just this basic E. coli. So the treatment should not be the same. So this is how they came up with the sector-based effluent standard. And also there's treatment-based effluent standard, which is asking the permit holder to treat water to a stated standard also in order to be released to the environment. And also there is water quality based effluent standard, which now also depends on the use of water, because you may treat water to a point where it will be used for domestic, and you may treat it to a point where it just need to be used in agriculture. That is, even if it still have high concentration of some minerals, it may be okay, since the plants also need those minerals. But also you may treat to a point where it is to be released to the environment, so you just need to take care of the biodiversity and other aquatic organisms not to be harmed by the released water to the environment. So looking at the scope of Tanzania, Tanzania has a wastewater discharge permit, which is usually provided by National Environmental Management Council, and the prerequisite to obtain this discharge permit is to conduct environmental impact assessment before you start the production process or even construction of your
Hello, Dr. Clarence?
Yes?
You first for a second.
Hello?
No, please proceed. You first for a second. Please proceed.
Effluent for a particular production, and also the environmental impact assessment will look at the environmental impact surrounding the industry and how the ecosystem surrounding the industry is going to be affected by whatever effluent that come out of your industry. And now, why do they need a permit? A permit is important because we need to limit the pollution. Also, we need to monitor the effluent standards from time to time. And this is, for the case of Tanzania, this is done by the National Environmental Management Council officers who visits these industries from time to time, just to confirm the effluent standard, if they are complying the given effluent standard. And also we need permits to meet the treatment protocols, and also wastewater management is responsibly adhered, and also we need to adhere to environmental standards. That is why all processing industries or manufacturing industries, they need a water discharge permit. Now, when the inspectors visit the particular industry, they look for compliance of the effluents to the stated or to the given standards. If the industry is not complying to the stated standard, then it can lead to penalties, or they can revoke the permit. Yeah, please, next. Yeah, so we do also have, as we saw earlier, we saw that some of the these contaminants, they can easily move into the groundwater system. So we saw a need to look up into the groundwater protection. And looking at this, we may see that groundwater accounts for 97% of the global freshwater resources. And also it is essential to human and economic development. As we have seen in the previous lecture, we saw how groundwater is used in different purposes. We saw it accounts for, it is used for irrigation. It is also used as a drinking water, specifically in rural areas. And it is also used in industries, including mining sector and other industrial developments. So how does groundwater occur? What is the setting that allow the groundwater occurrence? Now, if we look at the right image, we'll look at the this image. We see the trees on the surface. We see the surface water body on the right, and going down, we look at the unsaturated zone, where water, when rain falls on the ground, water percolates down, and as it passes through the, if it manages to pass through the unsaturated zone down, it will move into the groundwater system when it passes through the water table. And if it flows horizontally, it will be called a base flow. That will usually it flows to the nearby surface water body. So but as water enters the groundwater system, it needs these openings or fractures which are between the rocks, where water can be stored. And for a body of rock to be termed as an aquifer or a water storage system, it should be having these porosities to a percentage that can allow water to move through it and yield to a well when a well is drilled to this particular point. So that is how we come up with the groundwater system. And as we can see, it's really vulnerable to the waste effluents from these industrial sectors, especially for the boreholes, for the shallow wells, which are drilled on the, mostly they are drilled on the shallow surface in the unsaturated zone. So you see if the effluents come from the industries or from even from the from petrol station. If they have the leaking tanks, they may release hydrocarbon to the groundwater system, which is on the shallow depth. Let's go to the next. Next, please. Yeah, if we now look at this, we may see the sources of contamination in groundwater system. As we have seen earlier, we do have industrial effluents, which is discharged from the industries. We also have leaching of the rainwater or precipitation, which is carrying the waste which was washed away from the surface. When leached to the groundwater system, it will end up contaminating groundwater. Also from the landfills, the leachate may infiltrate to contaminate groundwater, and also from the storage tanks, such as oil or petroleum hydrocarbon storage tanks. Also, erosion may be caused by, erosion can also lead to the contamination of groundwater system, since the erosion may wash out some heavy metals which were abandoned or left on the surface of the ground, and it may end up finding its way to the groundwater system. Also, old landfills and sites also is another factor that can also contaminate the groundwater system when it's been improperly abandoned, and when it was an open landfill. Next, please. Yeah, now what are the risks of contamination? The contamination may lead to economic impact, such as a reduction in economic growth resulting from a lack of clean water. So if the water is contaminated, of course, the contaminated groundwater is harder to remediate compared to the surface water bodies, since surface water bodies such as rivers, they are flowing. So when contaminated, they may wash out and we have new water coming. But for the groundwater system, since also its movement process is really slow, so cleansing the groundwater system once contaminated is really hard, and as a result, we may have an access to clean water for economic activities. Also, it may pose diseases to human who have access to such water, and also the food security may be affected, since the water, when it's contaminated, it cannot be used to a point that cannot be used for irrigation. It's also costful for industries, since for industrial processes, they will need more funds for processing, since when water is mostly contaminated, the treatment cost will be higher compared to the potable water. Also, in the climate change mitigation, as water availability becomes more variable with climate change, groundwater also become more important, and as a result, we'll be having overpumping the groundwater system. As a result, we will end up with the adverse impacts which are caused by the overpumping, such as saline water intrusion and land subsidence. Next, please. Now, what do we do after if we do have the contaminated system? What are the mitigation measures? So if we do have this contaminated system, of course, as I said, cleaning the contaminated groundwater is really hard and it takes time. But what can just be done is to conceptualize the aquifer and the pollution, which is by modeling processes which can indicate the contaminant transfer through the groundwater system. And you may even be able to detect the source of the contaminants. So we may try to limit the source if it's within our capacity. We can also collect representative samples and design and build monitoring network and infrastructure so as to keep monitoring the groundwater system and make sure that we are doing all the effort necessary to remediate the system as we keep monitoring. And also we may delineate the source protection zones since we may do mapping of the groundwater recharge zones. And after knowing the recharge zones, we may declare it as a protected zone. Such incidents happened back then in Maktupora Basin. As we all know, the Tanzanians know, Maktupora Basin is the main source of water for the Dodoma region. And they once had so much concentration of nitrate and phosphorus, which comes from the human and animal excretes. And what was done was to declare the land as a protected land by resettlement of the people and all the human activities that were taking place around the area. So the area is of now, it's a protected land and there's no any human activities such as agriculture and any other activities or resettlement. Like the area is now a protected zone, which is being managed by the IWAMI Roof Basin officers. Also, we may manage the existing contamination by having an action plan that is enabled once a contamination is detected and share information. This can only be observed when we are having the groundwater monitoring network that is giving us the real-time data to inform us with the groundwater contamination immediately as it occurs. Thank you. Let's move to the next. So after looking at the groundwater contamination, now let's look at the water scarcity for industrial processes. We do have effects of having water scarcity in our industrial processes, such as disruption of the production processes, which will increase costs and force industries to seek for expensive alternatives. Since once a certain source is out of range of out of use, then the industry will be forced to move into the alternative source, which may be expensive and increase the running cost of the production processes. Also, it may lead to the power plant may reduce its output or completely shut down, since if there is no water for power generation, then it cannot be in operation. Also, water scarcity can worsen the water quality and increase treatment costs, as we saw earlier. And also, limited water access reduces efficiency and forces costly investment in the alternative sources, and overuse also harms the ecosystem, pushing industries towards costly sustainable practices. since as we have seen several cases when water is reused, for example, water from these small water bodies such as small dams, during the dry season when water is overused, we end up having the ecosystem disturbed. You'll find some of these aquatic organisms dying due to lack of enough water in the water body. So now, how do we control the water scarcity in industries? We may control by looking at the alternative water sources and such as having rainwater harvesting in-house, which does not need much effort, and by having rainwater harvested, we may have it as a reserve that can back up during the water crisis. And also we may have water efficient technologies, especially in areas like in irrigation sector. We may apply the efficient irrigation system like drip irrigation instead of going for flood irrigation, which needs a lot of water. And also we may adopt circular economy principles where we reuse most of the water to be reused by the industry in the same processing use or in other uses such as washing and sanitation. Next, please. So conclusively, we see that water demand is rapidly increasing due to economic and population growth worldwide. But management is crucial for industrial resilience and environmental protection. And also water efficient technology and pollution control measures should be adhered to make sure that we manage this vital resource sustainably. And also regulatory frameworks should play a key role in balancing industrial growth with the sustainability, such as using those water use permits and water discharge permits. This will always balance the sustainability of the resource. And also future industrial processes depends on integrating environmental protection into long-term planning process. Yeah, next please. So I would like to thank you for your attention. I hope we still have everybody on board. So now it's time to pose your questions and inputs, and if you have more clarifications on what has been presented, you are all welcome. You just start by telling us your name, and then you come up with the contribution or question or discussion. Thank you.
Wow,
Over
we
to
have a
you.
first hand raised. Thank you so much, Dr. Clarence. I see Martha was burning with this question because she raised her hand first. Martha, welcome.
Okay, thank you so much, madam. I have a question here based on the concept that you have explained about the percentage of water in the irrigation system, percentage of water in domestic uses, and percentage of water in industrial uses. As I've said that 97% of the water they have been using in irrigation system. So if the percentage of the irrigation system has become so high compared to the percentage of the water used in industrial purpose, I would say that in industrial purpose, the percentage of water that has been used is 25. Is it true?
The percentage of water used in irrigation is just 40%, and the water used in the industry is 25%. Of course, these variations comes with the world we live in, which is a third world country, where the industrial development is low compared to our fellow colleagues who are developed, who have so much consumption in the industrial use. But for us, I think 97% is just the amount of the freshwater contribution from the groundwater system. Out of 100%, the 3% comes from the surface water bodies, and now the remaining percent is from groundwater system, which is an invisible resource, which we need to monitor for its sustainability, because as we see, it's saving a lot in our economic activities. So the percent is not 97, it's 40% in irrigation and 25 in industrial use.
Thank you.
Hey, Martha, thank you so much for your question. Any more questions, comments, experience sharing, notes that you wish to exchange with fellow classmates and the facilitator today before I start calling out names? Okay, is it Martha again? Okay, Martha.
I didn't finish my question.
Yes.
Oh, apologies. Please proceed.
Oh, Madam Kisiki, say that
Yes.
I've been eaten up for some amount. Some of the water going to be left as water. So we see that here, percent will be high. So what should we do so that we can improve the percentage of water in waste sector, so that it can be left as a pure water to be used by other people in our country?
Would you repeat, please, because I think your internet is not stable.
Okay.
And yeah.
Okay.
Yeah.
You as the water being eaten up, some of the water will be evaporated, and
Yes.
the left one will be used as wastewater. So we
yes.
The percentage of that can be turned into wastewater has become so high in our country.
Yeah. Yeah.
What do we do so that we can reduce the percentage of the water that will be used as the wastewater, so as to be as the pure water?
Yeah, I think we had this conversation last time, and the module for wastewater recycling is coming. I think it's 3rd or 4th, Mwamini. But from this point, the wastewater can be reduced by, last time we had this conversation and we saw that we do not have, currently we do not have policies or guidelines which are demanding these industrial water users or any other organizations which release this wastewater to the environment or to the treatment plant to recycle this water and reuse for themselves. So and also, you know, the issue is, you know, treating water is costful. Like treating it to a standard that can be reused is costful. But now, if you are able to access the potable water, which you can treat at low cost, there's no way you will move into treating this polluted water, which has probably like some heavy metals and other contaminants. Treating it is more costly compared to having fresh water from these abstracted surface water bodies. So having the rules which guides them to use water at least twice before it is released to the environment will save the case in making sure that people are using water efficiently and reuse instead of abstracting more water from groundwater system and from the other surface water bodies. So this is not in our hand. Like we can just advise the government to come up with these guidelines which will maybe once they will be given these permits to be directed to make sure that they reuse water before it's released into the environment. However, we had some people saying we have some few industries which are already practicing voluntarily, but now this has to be monitored by government in order to have a successful implementation. Yes, Martha, did I respond to your question?
Yeah, it's okay, madam. I've understood you now.
Thank you so much, Martha, for the question, Dr. Clarence for the clarification. Looks like one of our classmates will drop out soon, but maybe he could go first. William, do you want to go first before you drop out? William Gilly? No, he's...
Hi.
Hi.
Hello. Can you hear me?
Yes.
Okay.
Yes.
Very good. Yeah. Thanks, Dr. Kisiki. Thanks, Momini. Hi, everyone. I came in a little late because I have a family issue to deal with. But there was a point where Doctor talked about the Makutupora area, that the area is now protected due to some surface contamination. I could not hear it very well. Can she just go over real quick for me so that I understand? I'll follow up by finding sources so that I could read on my own. But I just wanted to get some insights on what exactly happened. And then that's it. Thank you.
Yeah, thank you so much. I gave that as an example of protecting the groundwater system, as I was explaining about the sources of contaminants, and I said once the groundwater system is being contaminated, the best solution among the solutions we may have this the protection of the recharge zones of this particular groundwater system, because there are several scientific approaches which we can go through to identify the recharge zone of a particular groundwater system. So in that aspect, I gave an example of the Makutupora Basin back in, I think it was gazetted to be a protected zone in 2007. But back before this 2007, the several studies were identifying the pollutants in the groundwater samples, such as nitrate and phosphorus, which is usually comes from the agricultural flows, and also from the animal and human excretes. So due to that, then and due to the importance of this particular groundwater system, since we all know that for now it's the major source of water for the whole Dodoma region. So the government had to reallocate the people who are living in that particular and compensate them, and then they had to resettle from that particular area, and now it's gazetted as a protected zone, and there's no more agricultural activities and human activities or settlements which are currently in place around the Makutupora Basin.
Thank you very much. Makes sense.
Thank you.
Thank you so much, Dr. Clarence. I see a chat from, just a second, I'm having a hard time scrolling. Okay, so maybe while we're scrolling, let me just open it up to Constantine's before I go back to the question on the chat. because I can't scroll. Constantine, do you have any comment?
Yeah, thank you, Mamini. Thank you, Doctor, for the great presentation. It was really interesting to listen. I think the question comes to, when it comes to environment and wastewater discharge, comes to proper reinforcement of the policies and laws. And I think it's a question more to do with the policymakers and the government. And I just want to hear from you, Doctor, how do you see the enforcement of these policies within Tanzania, and where do you see, the government's looking into that, or this is more as academical side of the problem at the moment in Tanzania? Thank you.
Thank you for a great question. Currently, personally, before I moved into academic institutions, I was working with the basin office, and among our duties were inspecting this discharge permit, because we were managing the water bodies, surface and groundwater system, and now we were working with the Environmental Management Council into looking at the compliance of this or enforcing these policies and laws to these industrial water users. The government is trying. It's level-based. However, I cannot say it's the best, since the inspection itself is not done like timely, and also you see this some people would always look for an opportunity. When you fail to do your part, they will always cheat on some things. So we, for example, we had gone to a certain industry. I will not mention the name, and we found out it's a textile mill. They were doing production, and they were having an effluent which is typically black, which means it's totally contaminated. But when we went to the water treatment system, waste treatment system, it was dry, like it had no water for like 3 years or so. So we're wondering, where was the wastewater going to? So at the end, we realized that those guys, they were directing that water to the groundwater system, to an abandoned borehole. You see, so we do have such cases, like the inspection of these industries is not timely done. The management is really not in a good situation. So I think there's a need to add more effort in this particular area to make sure that our environment is well protected, and probably they need to have more charges to defaulters who fail to comply with the stated discharge requirements.
Thank you, Doctor. I have one question, if you allow me to ask, specifically for wastewater networks. In Tanzania, is it combined system or it's separate systems? Because combined system usually create much more issues for environment rather than separate system, where we have wastewater and stormwater into isolated networks.
In Tanzania, it's isolated system, and we don't have so much of the wastewater network. Rather, it's more of the stormwater network, and we do the households or residential areas which are connected to the wastewater networks are those built during the colonial period. But and a big institution like Muhimbili National Hospital, but rather other households and other industries, they have on-site disposal systems.
Thank you. Clear. Thank you.
All right, thank you.
Much, Constantine and Dr. Clarence, for that exchange. The question was from Jasmine. I'll just read it. So
Yeah.
it says that in Dar es Salaam, there are valleys through which water flows from factories such as Msimbazi, Kibasila, and Mzinga, and small-scale vegetable farmers use this water to irrigate their vegetables. So the question is, what are the effects of this water being used to irrigate vegetables? Why aren't there relevant authorities taking any action, any industries that leak water, etc.?
Yeah, that is I'm aware of that, and you see, along especially Msimbazi River, we have several industries which are built along the Msimbazi River, and most of these industries, even the households along the Msimbazi River, during the rain season, they would all release their effluent towards that Msimbazi River. And as a result, the water flows downstream. And of course, now that is where the implementation of these laws and policies become like not well implemented. So since because everybody is seeing that happening, everyone is seeing Msimbazi River being so much polluted by these effluents, but now sometimes they would take action, and sometimes they would just take business as usual. That is how we live. But now, as this water flows down, these small-scale gardeners or vegetable agriculturists usually irrigate these vegetables using this water. And these are the vegetables which are taken by almost the whole Dar es Salaam households. And I have seen several studies which indicated the existence of heavy metals in these vegetables, which are grown in this at the banks of these rivers. So it's really threatening the health of the users, and also I'm sure all these are known, and but now it's just to take a measure first to stop these people who are producing vegetables from that particular river banks, and also to make sure that they can work on the effluents which are released to this river system. But now the implementation of this of the compliance and the implementation of the enforcement of the laws and regulations, it's on the government institutions. It's not like most of these, like the scientists or researchers, they will just find out what is going on, what is the problem, and they would publish, like it will be online published, they would like share in the conferences and public sectors. So it's up to the responsible institutions to act on the matter and try to rescue the health of the citizens. Yep.
Thank you so much, Dr. Clarence.
Thank you
for the clarification. Jasmine, I hope that is satisfactory. Yeah, okay, so maybe just a quick call of names so that everyone just gets to participate and just ask or comment. If they don't, then they'll just say nothing. So maybe Ali Mwajiri.
Ali Mjawiri, thank you for giving me a chance.
Mjawiri, sorry.
Yeah. Thank you. I want to ask a question. We know that Nigeria is a source of water bodies. What's the effect when the mountain erupt to flow mountain magma to the rivers. Do you understand it?
I didn't get the question.
No, can you maybe move closer to your microphone? I just heard magma.
Yes. Magma, when the mountain erupts, what is the effect of mountain magma to flow to the rivers or water bodies?
Yeah.
You want to know the effect of magma flowing into rivers or water bodies?
Yes.
Do you have a
Okay,
specific example?
The Kilimanjaro, like in Tanzania, but we need to erupt. Kilimanjaro is volcanic. What if of mountain magma to flow to the river? Is it safe to use the water or is not safe? Is it polluted?
Do you have a recent? Yeah.
I think he just wants to look at it from a pollution perspective because he thinks or he sees magma as a pollutant, if that's the correct word. So he just wants to know, from that point of view, from a pollution point of view.
Yeah. For a magma to be a pollutant or not a pollutant, it cannot be directly called a pollutant because magma is what rocks are made up, right? When magma erupts, as it solidifies, it makes a rock, right? Yeah. So for a magma to be pollutant or not a pollutant, it depends on the composition of the magma, like the mineral composition in a particular magma. Because now you see we have some rocks inside the riverine system, right? Water is flowing within the river and the water is not polluted, right? By these rocks. So magma is just a rock in a molten form. So whenever it is poured into the water, now it depends on the mineral composition. If it has like mercury or arsenic, or if it has any of the cadmium or whatever the metals, then that would be a pollutant. But if it's just having the stable minerals which cannot pollute the groundwater or react to the water molecules, then we cannot call it a pollutant.
Thank you.
So the important thing is just to measure the quality of water after having the magma erupted into the water, and then you will just know the quality of water and if it's fit for use or not.
Okay, thank you.
All right, thank you.
Thanks, Ali. Benjamin?
Yes, thank you. Thank you, Doctor, for the great presentation. Yes, I think most of the questions have already been asked. Yeah, so I think about just to improve on the integration of this protection of water bodies is just it's going both ways. Kwanza ni kuanzia the user himself, then and the government, how to, what are the regulatory policies and laws that they can implement on their end. So yeah, though I just have one thing, if you can advise, as you can see on your presentation, 40% of the water has been used in irrigation, and it's I don't know, is there any an innovative way where we can try to improve the water that is used in the irrigation, or before or after the process itself? I think that's it. Thank you.
All right, thank you, Benjamin. I think having 40% used in irrigation, actually the statistics says in Tanzania, we are not, you see, sometimes we are subjected into food shortage, right? Food insecurity. So the statistics says we are not practicing the irrigated agriculture enough. Like most of the farmers rely on the rain-fed agriculture. So having this 40% amount of water used in irrigation, yes, it's huge sum, but it's because it's the use is not efficient. But now the problem comes with the application of the efficient use of the irrigated agriculture, which goes with so much costs, as we know. Practicing drip irrigation, it's costful, right? The first installment is costful. So that is why you would find so many people going for flood irrigation. So if we are to campaign on the moving into the drip irrigation, we'll have so much water conserved and we'll have sustainable sources. But now we do have to see how to capacitate these farmers to access the funds that will help them to have that initial installment of this drip irrigation systems. So I think the campaign should go with the funding sources because as we know, most of these agriculturists, they mostly they have 2 hectares, 3 hectares. So like we find there are people who cannot, and if they are having a very big farm, again, installing this, the system is even more costful. So we have to find a way of coming up with these solutions, but also capacitating them.
We're funding them.
Yeah.
Yeah, thank you.
Thank you so much for that. 𝐀𝐻𝐿𝐵?
Yeah, thank you. I have no comment till now.
Okay, thank you, 𝐀𝐻𝐿𝐵. Dare Peter? Dare, do you have any input to contribute?
Thank you very much.
Yeah, Dare, I can faintly hear you. Was your input? Thank you very much.
Yes, I'm good. I'm good with everybody.
Oh, you're good. You're good. Okay, cool. Thanks. Flora? Okay. Flora seems okay.
Nothing to add. Just want to thank Dr. Kisiki for this valuable discussion. Looking forward for the coming session.
Thank you, Flora. Just so that you know, Dr. Kisiki will probably see us in the in-person training on the 8th. Again, today is her last session in the webinar. Mr. Mrema?
Yes, Mwamini, thank you very much indeed. And thank you also, Madam Dr. Kisiki, for a very powerful presentation. Appreciate a lot. I have one question on the agriculture. I think we're touching on the 45% use of the application of water, which is mostly flooding type of irrigation. Is much of it is going into wastage. But my question is on the, I think some of the contaminations in the agriculture could be as well use and application of fertilizers. And I am not sure whether Maybe I slept on it. Maybe it was touched or it was not touched, but I'm concerned about this, the application of fertilizers. And we are aware that most of the fertilizers are imported. And we are hearing a lot of noises, some are fake and things like this. My question is, on the utilizers, are the utilizers imported or locally produced regulated as similar as you know, the other side of you know, in the health sector of maybe veterinary drugs for human medicines? We know exactly these are regulated by TFDA. What about fertilizers? Thank you very much.
Thank you so much, Mr. Mrema. Looking at the fertilizer as the source of pollutants, yes. Fertilizer is some produced in our country and some imported, since we cannot meet the demand for the one made locally, so we usually do import. But in terms of the regulation, we all know that for a fertilizer is just these nutrients which are needed by plants for its growth, which mostly it's a nitrogen, phosphorus, and potassium, right? Yeah. So excess of anything is harmful. So whether the fertilizer is locally made or imported, it should be having these nutrients which are needed by the plants. But again, the plant cannot uptake all the nutrients which were supplied in these fertilizers. Some will be washed out during rain season, and then it may be percolating to the groundwater system. And this case came when I was giving the example of the 𝐸𝐺𝐻 basin. They used to find the contaminants which were coming from the fertilizer or from agriculture and from the human activities, other human activities such as like excretes and other pollutants which are generated in our day-to-day activities. So in the case of a regulatory body, I'm sure this is regulated under the Ministry of Agriculture, but I don't know the exact organization which is responsible for this, but we know there are some people who has this license to import the fertilizer, just like the politics of sugar. We have like few giants who are licensed to import the fertilizer and to import the other products such as sugar. But now this is the source of groundwater pollution, and we call it a non-point source, because we do have point source and non-point source of the pollution in whatever the system, if it's groundwater or surface water. There are these sources which we can tell where exactly the pollutants are coming from. But we do have these pollutants which we do not know exactly where the pollutants are coming from. But just by knowing the type of the minerals, we would know this must be coming from agriculture and this must be coming from the industry. This must be. So it's our responsibility to make sure that we are following up and knowing if we have agricultural lands nearby this groundwater system. And now you see, like, the measures which were taken by the 𝐸𝐺𝐻 well field was to relocate the people who were living in that area to to make sure there is no these activities going on. But again, if we look at the parameters which are required to be in our daily drinking water, we have this nitrate, we have, I mean, not nitrate, nitrogen, phosphorus, and potassium, but we have a limit, like it should not exceed this much. So if it's exceeding the amount, that is when we call it pollutants. So now it depends on the how much will manage to be transferred and enter the groundwater system. And in most cases, when we are using the shallow wells, that is when we will encounter several pollutants coming from the flash floods, since these are the wide boreholes, which most cases are open. So you may find these pollutants easily entering the system. But when we are using the deep groundwater system, I mean deep wells, which is 100 meters, 80 meters and more, then we hardly find having this as major pollutants, since during the construction phase, the person who is constructing should take care of all this and make sure they cement in the upper parts where the this groundwater, I mean, where these washed out minerals can enter the groundwater system. And also, as water moves towards recharging the groundwater, it moves towards the soil, and it also passes through the rocks, and these rocks and soils act as filters which keep filtering this water to the point when it gets to the groundwater system, you find it cleansed at a reasonable range. So having this in mind, we may find out that most of these contaminants from agriculture wastes are mostly found in the shallow wells, which are mostly not recommended to use for human consumption, but we just rely on them just because we do not have these mechanized wells which can supply water, which is safe for human consumption. I hope I responded, Mr. Mrem.
Yes, indeed. Thank you very much, madam.
Thank you.
Hello, Dr. Yes, I'm
Yes.
here. I'm here. Sorry, I just dropped out for a bit. Yes, thank you so much for the exhaustive clarification, because we are almost winding up. Maybe Jasmine, Kennedy, Sophia, and do you have any more questions?
Oh, yes. Thank you, Mamin, again.
Okay, okay. Kennedy first, okay?
Okay. Did Jasmine want to go first?
No,
No
just
worries.
proceed.
Yeah, I think yeah.
Okay, I was trying to be a gentleman, by the way. Sorry, Jasmine, you want to go first. Okay, thank you, Doctor, for the great session, and the person who asked the questions. They were very insightful. They actually consolidated on the topic. But my question goes about, from your experience, you said you have worked on the basin and currently in the lecture now. So my question was, are there any practical solutions to tackle this monitoring issue, where the government goes to inspect and finds an issue or mismanagement of the waste disposal, and it turns into business or no follow-ups? I believe you know the challenges. So I was thinking, is there any best solution to this? So maybe you can recommend to the government or the government officials. Thank you.
Yeah, thank you so much. As I said earlier, we do face all those challenges while we are in field, and the best we can do is just advise the responsible authorities to take action on the defaulters of the laws and the set guidelines. But otherwise, Now, I don't want to go into detail on this, but you know, there are several things which can take place like behind that. After leaving the case with the responsible authorities, now it's up to them on what is to be done, like to find them or take them to the court or whatever the solution they come up with is stated in the guidelines. But again, for the scientists, as I said earlier, we just find out the problem and give we advise like what to be done. But now in the doing, it depends now on the implementers of the policies and laws of the country. Did I answer, or I've been too political?
I'd say that it's still political, but as I can see, as for example, the issue of Msimbazi River, it's an issue which has been talked over and over for years. People disposing their waste, but we see the government has not taken any actions. We do not see people going to court or filing lawsuits, something like that. For me, still is a challenge as we see the eruption of a lot of diseases. So I don't think we should stay in politics.
It is really a challenge, and also because in such an issue, it has nothing to do with politics, of course, because it's not like you are going to hold on all the people living along the Msimbazi River. You can point out who exactly is releasing the effluents to the environment. But now most of the challenges most of the solutions which comes up with this problem is cleaning the river. And we have some NGOs who are cleaning the rivers and trying to see how to clean the river without most of people are not dealing with the source, they are dealing with the outcome. Which is difficult to eradicate the problem, because you should start from the root to the outcome. But now if you just deal with the outcome, it's impossible to stop the acts of releasing these effluents to this particular environment. So I think it's high time I may take this as a challenge, and because I'm working with the Water Institute. We are all under the Ministry of Water. We do have this basin water offices, which also they are our brothers, and we do work together in several aspects. So let me take this as a challenge, and I will try to raise the voice to these people and see what can be done. And for them, they really work closely with the National Environmental Council, because the major environmental law is the water law and environmental law. Water law comes first. Environmental law comes first before the water law. So they usually work very much close with the National Environmental Council in dealing with such issues. So it's very, very easy to just make sure that all these people are having this wastewater treatment plants, and they are complying to the standards. But we always have these people, even these households. You find sometimes when it rains, unakuta amenyesha manyunyu tu, but you find so much water flowing in the streets. So people have already opened their pit latrines, and they released water to the environment in the name of it's raining. So this is the flooding coming from the rain. So we have such cases which sometimes it's unavoidable, but they have to at least do something to minimize the waste which is released. So I accept this as a challenge, and I will try to work on it. And I think I'll have your contact and give you or you will see it cleaned after sometimes.
Yes, and added to that, I see also there's a loophole in our laws. The Environment Management Act of 2024, most of them, they're not amended. I believe that's something we should be in attention.
Yeah, and also, you know, the problem with us is thinking that like everything is for the government, but government just come up with the laws and it's for us to implement, right? The enforcement is on our side. But now if we all keep violating these laws, then we'll make environment not a good place for us to live. You see, because now we are posing several threats into this environment, which make it harmful for our own health and the other ecosystem environment.
Okay, thank you very much, Doctor. I'm just Kennedy from ATAWAS. We'll talk much more in detail when we meet in person.
And you, Kennedy, I know you have been cleaning these rivers also.
Yes, very much, Doctor.
What is the progress?
The progress is currently a bit challenging as we talked before, but most of the time what we do is just provide education to the community around the river. But still,
right? Yeah. Community sensitization is really important. Just like we need to start changes from ourselves, not from the government. But I hope with this industrialization growing, I hope we'll try to come up. Yeah, we'll meet in the Magi Week and other congregations which will make us discuss this further with these key stakeholders, right?
Absolutely, Doctor.
Thank you so much.
Thank you very much.
Thank you, Kennedy, for being a gentleman, going first. So, Jasmine, please proceed.
Okay. Thank you very much, Doctor, for the pleasant answers and for taking as challenge and raising about the wastage of water in Msimbazi. It really affects the majority of people, but they don't have voice to speak. So thank you very much for taking it.
Thank you so much.
Okay, Sophia, Stephen, Susanna, any of you want to say something? Susanna, yes.
Okay. Hi, everyone. I want to add some inputs. In case of water waste, I think we can cooperate with local governments to do something like to involve local communities to be part of it, work on it, like to be a defenders to protect some areas which have the water sources, to prevent pollution, to prevent people who come there and make pollutants. I think that it can be my input. Local community involved.
Thank you so much, Susanna.
Yes.
Thank you so much, Susanna. We take that input and sincerely appreciate. Sophia?
Thank you.
Yes, Sophia. Okay, no comment from Sophia. Last but not least, Stephen. Okay, no comment from Stephen. So everyone, thank you so much for participating. Dr. Clarence, as always, you're amazing. Thank you so much for taking us through the 2 modules. So the next time the rest of the class will see and hear from you will be in the in-person training scheduled on the 11th, but they'll also get to hear from you on the recording that you did on ATINGI, like the e-learning. So after all this, you can have like some sort of recap on the e-learning, which is friendly and easy to navigate. As we promised last time that we're supposed to activate the e-learning phase as of today, but we're yet to hear back from our colleagues from ATINGI because the course is still undergoing some quality checks, but it shouldn't be a problem because a significant portion of the content is provided through this e-learning. The ATINGI phase is mostly going to be a recap. You're also going to see the module books and some of the recordings Dr. Clarence and Dr. Magori recorded in relation to the content. So for next week's webinar series will be with Dr. Magori Nyangi, who will take us through issues related to wastewater and wastewater treatment. But if you have any questions for Dr. Clarence, please do not hesitate to reach out to her. Or if someone wants to, you can always reach out to me and I can connect you with her. Too, you can connect with her on ATINGI once we go through the quality check and pass it. Like we'll have the discussion forums to continue the discussions, but also just in a few weeks, you can connect with her in person during the training. Other than that, thank you so much for being with us for the past almost 2 hours. And I think that's it. Dr. Clarence, any parting words for the class?
I just thank everyone for being around for all this while. And I thank you also for the active participation. It was really interactive and insightful. I thank you, Mwamini, for the smooth coordination. So I hope to see you physically in the coming, I think, 3 weeks. I will keep posted by Mwamini on the venue and everything. Thank you.
Indeed, indeed. So have a great afternoon to everyone. Thank you so much. Bye.
Thank you so much. Bye-bye.
Bye-bye.
Bye.